Hi friends, welcome to Aptitude videos. Here in this video we are going to learn divisibility. Let's start with that. I hope you have studied up to 11 in 9th class or 10th class. But here we are going to learn up to 100. Up to 100 they ask me about any number, how to check for that number. I should be able to check it. So let's start with 2. How do we check a number is divisible by 2 or not? For example, let's say a number is 37,472. Is it divisible by 2? I'm going to check only the last digit. The last digit here is 2. 2 is divisible by 2, so I can tell this number is definitely divisible by 2. So the point here is, if a number is ending by 0 or 2 or 4 or 6 or 8, then that number is definitely divisible by 2. You can see here 37,472 is ending by 2, so this is divisible by 2. But I'm going to write one more point here. Now if I ask you how do you check for 4, you'll tell me checking the last two digits. For example, here the last two digits are 7 and 2. Is 72 divisible by 4? Yes, it is. In that condition, 37,472 is also divisible by 4. So we are checking the last two digits. See here, checking the last two digits. I hope now you are able to understand the pattern here. For 2 we are checking just the last digit, means one digit. For 4 we are checking the last two digits. For 8 we will check the last three digits. For 16 we will check last four digits. For 32 we will check last five digits, and so on. For 64 last six digits. For 128 last seven digits. But anyway, 5 digit or 6 digit number is going to be so big, it is also going to take time to check for 32. So 99% cases the companies will ask up to 16, not 32, not 64, because in such a less time they expect you to get the answer by using the shortcut. But here this shortcut is also not that effective. Let's go to next one. How do we check for 3? Let me take one example here. Let's say I have to check, is this number divisible by 3 or not? Let me check. For 3 the test is the summation of the digits. If the sum is divisible by 3, then the number will be divisible by 3. Let me check what is the sum of the digits here. 7 plus 2 9 plus 9 18 plus 6 24 plus 8 32 plus 6 30. 8 plus 1 39. Is 39 divisible by 3? Yes. In that case, this 72,96,861 is divisible by 3. But if I ask you this number now, is this divisible by 3 or not? If I ask you this, it is going to take some time to check it by adding them. You can see here 7 plus 9 is 16 plus 8 24 plus 6 30. It is going to take time to add it. So I don't want to add it. I want to check it without adding the digits. Let's see. I'm going to start either from left side or right side. See here, 1 is 1 divisible by 3? No. Is 1 plus 2 divisible by 3? Yes. Cancel the digit. If I found something which is divisible by 3, I'll just cancel it. Is 3 divisible by 3? Cancel it. Is 7 divisible by 3? No. But 7 plus 2 will be divisible by 3. But do we have 7 plus 2? No. 7 plus 8, 15. 15 is divisible by 3. 6 is divisible, 9 is divisible, 3 is divisible, 6 is divisible, 8 plus 1 is divisible, 9 is divisible, but 3 is left out. When one digit left out here, which is not divisible by 3, this whole number is not divisible by 3. But if I had 2 also here, now 2 plus 7, this is also cancelled. In that case, this whole number is divisible by 3. So if all the digits cancel, the number will be divisible by 3. So for 3, I'm going to write cancellation. How about 9? Is this number divisible by 9? Let's see. How about 9? How do you check for 9? The sum of the digits should be divisible by 9. Now the sum here will be 9 plus 7, 16 plus 2, 18. Again, it's going to take time to add them. Why don't we do the same thing once again? Cancellation. If all the digits are cancelled, the number will be divisible by 9. Let's check it. Is 7 divisible by 9? No. But 7 plus 2 is divisible by 9. Is 9 divisible by 9? Cancelled. Is 8 divisible by 9? No. 8 plus 1? Cancelled. Is 6 divisible by 9? No. Now that's the difference between 3 and 9. For 3, I can cancel the multiples of 3. I can cancel 3, I can cancel 6, I can cancel 9. But for 9, I can only cancel the multiples of 9. I cannot cancel 3, I cannot cancel 6. I can cancel 3 plus 6, that is 9. So here you can see, I cannot cancel 6 separately, but I can cancel 3 plus 6, that is 9. Similarly, 8 plus 1, 9. If all the digits are cancelled, the number is divisible by 9. So for 9 also, the method is cancellation. So 3 is done, 9 is done. 2, 4, 8 is done. Let's go to 5. How do we check a number is divisible by 5? For example, if I have a number, is it divisible by 5 or not? Now for 5, we just check the last digit. If the last digit is 0 or 5, in that condition, the whole number is divisible by 5. For example, here it is 73,375. The last digit here is 5. So this number is definitely divisible by 5. So we are checking last digit. I'm going to write one more thing here. 5 power 1. Checking one digit, checking last digit. Then how do we check for 25? Following the same pattern, I can tell for 25 I will be checking the last 2 digits. See here, if I'm checking for 25, I'll check the last 2 digits. The last 2 digits is 75. Is 75 divisible by 25? Yes. In that case, 73,375 is divisible by 25. So checking the last 2 digits. Similarly, for 125, I'm going to check last 3 digits. Let me see. The last 3 digit here is 375. Is 375 divisible by 125? Yes. 125 3s are 375. Because 375 is divisible, so 73,375 will be divisible by 125. Checking the last 3 digits. Similarly, for 625, we'll check the last 4 digits. Let's go to 10. How do we check for 10? If the last digit is 0, the number is divisible by 10. For example, 73,470, is it divisible by 10? Yes, the last digit is 0. Now 2, 4, 8, 3, 9, 5, 10 is done. Only 6 and 7 is left out. Let's go to 6. How do we check for 6? For 6, we are checking 2 and 3, both of them. If a number is divisible by both of them, that number will be divisible by 6. For example, is this number divisible by 6? Let me check. I'm going to check for 2 and 3, both of them. Let me first check for 2. Because the last digit is 6, definitely this number is divisible by 2. Half work is done. Now let's go to 3. For 3, I have to do the cancellation. 7 plus 2 cancel, 9 is cancelled, 6 is cancelled, 3 is cancelled, 6 is cancelled. Because all the digits are cancelled, this number is definitely divisible by 3. And in that case, this number is definitely divisible by 6 also. So when I wanted to check for 6, I actually checked for 2 and 3. If that number is divisible by 2 and 3, both of them, this number becomes divisible by 6. But my question is now, why do we check for 2 and 3? If you remember, we talked about something called coprimes. Here, 2 and 3 are coprimes. Now look at this statement. If a number can be written as product of 2 or more than 2 coprime, then instead of checking for that number, we could check for the coprimes. See here? if a number can be written as product of two coprimes, here 2 and 3 are coprimes, product of two coprimes, in that case, instead of checking for that number, we could check for the coprimes. That's why instead of checking for 6, we are checking for 2 and 3. If the number is divisible by 2 and 3, that number will definitely be divisible by 6 also. Now this coprime concept is going to help us check for any composite number up to 100. For example, if somebody is asking how to check for 12, whether a number is divisible by 12 or not, I'm going to find a pair of coprime for 12, which is 3 into 4. 3 4s are 12 and 3 4 are coprimes. So if a number is divisible by 3 and 4, both of them, that number will definitely be divisible by 12. So if I have to check for 12, I'm actually going to check for 3 and 4, both of them. Similarly, 15, I'm going to check for 3 and 5. 18, I'm going to check for 2 and 9. 20, I'm going to check for 4 and 5. 22, I'm going to check for 2 and 11. 24, I'm going to check for 3 and 8. 28, I'm going to check for 4 and 7. 30, I'm going to check for 3 and 10, pair of coprimes. 35, I'm going to check for 5 and 7. 40, I'm going to check for 5 and 8. And 42, I'm going to check for 6 and 7. So this way, they ask you to check for any composite number up to 100 or up to any number. If they ask for a composite number, I'll simply find a pair of coprime whose product is this number. And by using them, I can check for this number. That's all. This was about composite numbers up to 100. But then till now, we have not talked about 7, 11, 13, 19 and other prime numbers. How do we check for prime numbers? Let's take a number. For 11, we have a very specific formula, and then we'll come back to one common formula which can be applied for any prime numbers. For 11, we have, let's say the number is this one. I have to check whether this is divisible by 11 or not. What I'm going to do, first I'll tell you this. If I check from right side, this is first place, third place and fifth place, and this is fourth place. This is second place and fourth place. If I had to find the sum of all the digits at the odd places, now odd places are first, second, fifth, and the even places are second and fourth. So the formula for 11 is sum of digits at odd places minus sum of digits at even places. If that difference is divisible by 11, in that case, the number will be divisible by 11. Here, the sum of digits at the odd places are 3 plus 2, 5 plus 7, 12. Minus 3 plus 9, 12. 12 minus 12, that is 0. 0 is divisible by 11. Actually, 0 is divisible by every natural number. So here 0 is definitely divisible by 11. In that case, I can tell this number 79,233 is definitely divisible by 11. So formula for 11 is sum of digits at the odd places minus sum of digits at the even places divided by 11. Now I'm going to tell you another formula which can be applied for any prime number. This is called multiplication factor. First, I'll tell you the multiplication factor for some numbers. Copy that. Later, I'll tell you how to apply that. The multiplication factor for 11 is minus 1, 21 minus 2, 31 minus 3, 41 minus 4, 51 minus 5, 61 minus 6 and so on. It continues 71 minus 7, 81 minus 8 and so on. And if the numbers are ending by 9, for example 19 plus 2, 29 plus 3, 39 plus 4, 49 plus 5, 59 plus 6, 69 plus 7 and so on. I have to check whether 23,478 is divisible by 91 or not. Now if I try to check it normally by dividing by 91, it is going to take some time because 91 is a bigger number. But if I use the multiplication factor for 91 is minus 9. Now, how to apply the multiplication factor here? I'm going to multiply the last digit with the multiplication factor. 9 8 just 72 minus 72, because this one is minus 9. And after multiplying, that digit is cancelled. Cancel the digit after multiplying. So now let me subtract it. This is 5 and this is 7 2 2. Now once again, follow the same step. 9 into 5. 9 5s are 45 minus 45. And after multiplying, this digit is cancelled. Let me do it one more time. 7 5 2 and here 8. 182. One more time. Minus 9 into 2 minus 18, and this digit is cancelled now. So here becomes 0. Here comes a 0. Now because 0 is divisible by every number, every natural number, so this number is now definitely divisible by 91. This is how we apply the multiplication factor. But if you noticed, we don't have multiplication factor for 7, 13, 23. Then how do we check for that one? Let me take an example here. 84. Is it divisible by 21? If I ask you, you will tell yes, definitely. 21 4 ja 84. But can I tell if 84 is divisible by 21, it must be divisible by 7 also? 100% sure. Definitely it is also divisible by 7. Although the reverse is not true. If a number is divisible by 7, it doesn't mean that it is also divisible by 21. But if a number is divisible by 21, it should be divisible by 7 also. So 84 is definitely divisible by 7 also. Now for 21, I had a multiplication factor minus 2. Now think. By using minus 2, the multiplication factor, I checked that 84 is divisible by 21. And I know that if a number is divisible by 21, it must be divisible by 7 also. That means we are actually applying the multiplication factor minus 2 for 7 also. So what we are going to do? We are going to apply the multiplication factor minus 2 for 7 also. So for 7, the multiplication factor is minus 2. So I told you this, but how do we find the multiplication factor for any random prime number? What I'm going to do, I'm going to check the multiples of that number and try to reach a number which is ending by either 1 or 7, 1 or 9. Let me see. 7 2s are 14, not ending by 1 or 9. 7 3s are 21, ending by 1. That means I can use minus 2 for 7. The multiplication factor minus 2 for 7. Similarly, 7 7s are 49 is also there. So I could use plus 5 also for 7. Both will give the correct answer. Similarly, 13. 13 2s are 26. It does not end by 1 or 9. 13 3s are 39. Now 39 is ending by 9. So the plus 4, the multiplication factor of 39, I can use it for 13. Similarly, 23. 23 3s are 69. So I could use the plus 7 multiplication factor of 69 for 23 also. This is how we find the multiplication factor for a prime number. Now once we understood how to check for any composite number or any prime number up to 100, let's go to some questions. Question number 1. What is the least value that must be assigned to A such that the number 81963A745 is divisible by 9? Let's apply the cancellation method. 8 plus 9 is cancelled, 9 is cancelled, 6 plus 3 is cancelled, 5 plus 4 is cancelled. Now A and 7 is left out. But if A had the value of 2, now 2 plus 7 will also get cancelled. So definitely the smallest value of A is 2. In the smallest number consisting of only ones and zeros and divisible by 15. Now they're asking you to create a number which is divisible by 15. How do we check for 15? By using 5 and 3, both of them. But the number have to be created only by using ones and zeros, not by 2 3 4 5 6 7 8 9. How do we create a number which is divisible by 3? When the sum is either 3 or 6 or 9 or 12, but they're asking find the smallest number. So we'll take the sum as 3. So if I write 1, 1, 1 3 times, now is the sum 3? Yes, this is the smallest number created by 1 and zeros which is divisible by 3. Now half work is done. Let's go to 5 now. For the number to be divisible by 5, it has to end either by 0 or 5. But as 5 is not allowed, we can put only 0 here. So this is the number which is divisible by 3 also and 5 too. So now this number is divisible by 5 and 3 both. That means this number is definitely divisible by 15. In this case, how many digits are there? There are 4 digits here. So answer is 4. 7q minus 55q minus 17q. Then n is divisible by which one of them? And this question have come in CAT exam also. Now here, if I start checking it, it will take time to check normally. So what I'm going to do, I'm going to apply this formula. Whenever the question is like this, I'm going to apply this formula only. First, I'm going to check, is a plus b plus c is 0? Let me check. 72 plus minus 55 plus minus 17. Is it 0? Yes, it is 0. In that case, I can apply aq plus bq plus cq is equal to 3abc. So 72q plus minus 55q plus minus 17q will be equal to 3 into 72 into minus 55 into minus 17. So this whole number will be divisible by 3, 5, 11, 17, 8, 9, 18, 36 and so on, many more numbers. But which one of them are there in the option? If I look at it carefully, 3 and 17 are there in the options. So answer is option C. It is divisible by both 3 and 17. Natural number greater than 2, then n5 minus 5nq plus 4n is divisible by which one of following numbers? Now for this type of questions, first I have to arrange it. So let me arrange it properly. n5 minus 5nq plus 4n. Let me take n common. It becomes n4 minus 5n square plus 4. If I take n square equal to x, then I'm getting x square minus 5x plus 4, which can be written as n x minus 4 into x minus 1. And then I'm putting the value of x here, n square minus 4 into n square minus 1. After factorizing, I'm getting n into n minus 2 into n minus n plus 2, means n square minus 2 whole square, a square minus b square, n minus 2 into n plus 2. Similarly, a square minus b square, n minus 1 into n plus 1. But now I have to arrange it in such a way that I'm getting consecutive numbers. Let me arrange it. N minus 2, n minus 1, n plus 1, and n plus 2. You can see there are 5 consecutive numbers here, n minus 2, n minus 1, n plus 1, and n plus 2. 5 consecutive numbers. In that case, this number will definitely have 1 into 2 into 3 into 4 into 5 inside it, which means it must have 120 inside it. What I'm trying to say, first, if the question is like this, first factorize it and arrange it in the increasing order, showing that there are some consecutive numbers here. If there are 3 consecutive numbers, it will definitely be divisible by 1 into 2 into 3. If there are 4 consecutive numbers, it will definitely be divisible by 1 into 2 into 3 into 4. If there are 5 consecutive numbers, it will definitely be divisible by 1 into 3 into 4 into 5 and so on. So here, because it has 5 consecutive numbers, that's why it is divisible by 1 into 2 into 3 into 4 into 5, which means it is definitely divisible by 120. In 200 to 300, which is divisible by 2 and 3. Before solving this, Let me talk about the types of questions where they're asking to count the numbers. The numbers which are divisible by 2 or divisible by 3. This is the first type. Second type, the numbers which are divisible by 2 and 3. The third type, the numbers which are divisible by 2 or 3. And the last type, the numbers which are divisible by 2 but not divisible by 3. These are the 4 types of questions they can ask you. And here, if they are telling between 100 and 200, means 100 also not included, 200 also not included. But when they are telling from 100 to 200, here 100 also included, 200 also included. Understand the difference? Between means the age is not included, but from 2 means both the endpoints are included. This is very important. Remember this: last minus first divide by d plus 1. That is how many numbers are there. So let's find out how many numbers are there divisible by 2 between 200 and 300. The last one is 298, which are divisible by 2, and the first one is 202. Divide by 2 plus 1. So it is 96 divided by 2, 48 plus 1. 49 numbers are divisible by 2. Similarly, if I ask you how many numbers are divisible by 3, that will be last number divisible by 3, that is 297, minus first number divisible by 2, that is 201, divided by 3 plus 1. It will be 96 divided by 3, that is 32 plus 1, 33 numbers. How many numbers are divisible by 2 and 3, both of them? If I talk about the numbers divisible by 2 and 3, both of them, let me see. 202, 204, 206, 208, 210, 212, 214, 216, and so on. And the numbers divisible by 3, these are numbers divisible by 2. Numbers divisible by 3, that is 201, 204, 207, 210, 213, 216, 219, and so on. If you notice properly, you can see 204 is divisible by both of them. Similarly, 210 is divisible by both of them. Once again, 216 is divisible by both of them. These are the numbers divisible by both of them. Aren't they asking the same question? Numbers which are divisible by 2 and 3, both of them. And which are the numbers divisible by both of them? 204, 210, 216. Aren't these a number which are actually divisible by 6? Yes. So we found out, if they're asking numbers divisible by 2 and 3, we actually have to check for the numbers which are divisible by 6. But what is 6? 6 is actually the LCM of 2 and 3. So when they're asking numbers divisible by 2 and 3, we actually have to check for the numbers which are divisible by the LCM of 2 and 3, which is 6 here. So we can check for the numbers divisible by 6. Let's check it. 2 and 3. So we actually have to check for numbers divisible by 6. The last number divisible by 6 is 294, and the first number divisible by 6 is 204. Divide by 6 plus 1. This is 90 by 6. 15 plus 1, 16. There are 16 numbers which are divisible by 6. Between 2 and 3 and 2 or 3. Understand? 2 and 3 means 2 intersection 3. 2 or 3 means 2 union 3. You can compare like this. But when we have to find 2 union 3, if you remember, we actually have to find the 2 plus 3 minus 2 intersection 3. That's why when they're asking numbers divisible by 2 or 3, we actually have to find the numbers divisible by 2 plus numbers divisible by 3 minus numbers divisible by 2 and 3, both of them, which means the numbers divisible by the LCM of 2 and 3, which is 6 actually. So here the numbers divisible by 2 was 49 plus numbers divisible by 3 is 33 minus numbers divisible by 6, that is 16. This will be 66 numbers. There are 66 numbers which are divisible by either 2 or 3. How many numbers are divisible by 2 but not divisible by 3? Let me see what are the numbers divisible by 2. 202, 204, 206, 208, 210, 210, 212, 214, 216, and so on. So we have to find the numbers which are divisible by 2 but not divisible by 3. So I have to remove the number out of this. I have to remove the number which are divisible by 3. I can see here 204 is divisible by 3. I should remove it because I don't want this number. Similarly, 210 is divisible by 3. 216 is divisible by 3. So from all the numbers which are divisible by 2, we have to remove these type of numbers. Now what are these numbers actually? These numbers are the numbers which are divisible by 6. So when they're asking numbers divisible by 2 but not divisible by 3, we actually have to find the numbers divisible by 2 minus the numbers which are divisible by the LCM of 2 and 3, both of them. Subtract that and we get the answer. So here the numbers divisible by 2 was 49 minus the numbers divisible by 2 and 3, both of them are 16. So answer is 33. There will be 33 numbers which are divisible by 2 but not divisible by 3. That's all in this topic. Thank you for watching the video.